Hello, welcome to Chapter 9, Homework Questions 94 to 100. Question 94, match each graph below with the correct inequality. So you can see that A has a greater than sign, B has a less than, and then you have a greater than or equal to and a less than or equal to. So we can do some elimination in terms of each of these because A should be a dashed line. So that means 2 and 4 are out. And then you can also look at the slope and see that this has a negative slope, so that means 1 is out, and then 3 seems to be the right pick. We can also see that the y-intercept is at 2, and it does have a slope of -1. You could plug in the point 0, 0 to see that it is false. 0 is not greater than 2. So all those things apply there, but there is definitely, since it is a matching, we could get away with some stuff here by not having to do the entire problem. So it does look like A will match up with 3. So I'll do it this way. A and 3 go together. Now the other one that is a dotted line or a dashed line would be B. That would have to be 1. So B and 1 would have to go together by process of elimination there. And once again, you can see it does go through -3 with a slope of 2. If you did test a point, 0 would not be less than -3. So all that works the way we expect. And then C and D would have to be 2 and 4. Once again, we could look at the slopes of each of these. C has a positive slope, which would have to be 4, because 2 has a negative slope. So C would match up with 4. And double check once again, 0 is your y-intercept, slope of 1/2. You'd have to test a different point like 0, 2. So 2, is it greater than or equal to 0? Yes. So that makes sense. And then the last one, D, would have to then match up with number 2. And you can see your y-intercept's 2, and your slope is -2/3. If you test the point 0, 0 is less than or equal to 2. That is a true statement, so it matches up. So here's kind of our matching part of it, and once again, there's lots of different ways that you could look at that. You could do every single one individually and then match it up, or kind of, since it is a matching, as you know, you can do some process of elimination as well based on what you know. Question 95. Solve each inequality below. Represent the solution on number lines. So start with A. We have 7x minus 2 is equal to 3 plus 2x, and we change it to an equal because we want to look and find that boundary point. So we'll subtract 2x to both sides, and to do that we're going to solve for x. Add 2 to both sides. We get 5x equals 5, divide by 5, and x is equal to 1. So that's our boundary point. And we need to know if it's open or closed, and it is open because it's not included, it's not equal to. And then we're going to test a point, or test a value for x to see if it is true to the left or to the right of 1. So I'm going to plug in 0, and that's going to be 0, because 7 times 0, 0, minus 2 is less than 3 plus 2 times 0, 0. So is -2 less than 3? Yes, that is a true statement, so that means at 0 it's true, and then everything to the left of 1 is also true. So all values of x that are less than 1 would be our solutions. All right, on to B. We have 1/3 x, and I'm going to once again change it to an equal sign so we can find the boundary point is equal to 2. Multiply both sides by 3 to get rid of the fraction 1/3, and x is equal to 6. All right, this time the boundary point is closed because 6 is part of the solution because it is equal to. And then we're going to test the point, test x equals 0 again because we can, makes it easy. Plug 0 in, 1/3 times 0 is 0. Is 0 greater than 2? And no, 0 is not greater than 2, so we're not going to shade where the 0 is. We're not going to go in that direction. We're going to go in the other direction. And so these would be values of x that are greater than or equal to 6. On to C. I'm going to go ahead and distribute that 3, so that would be 6m minus 3 minus 5m is equal to, once again, change it to an equal to sign. Combine your like terms. 6m minus 5n is m minus 3 is equal to -1, and then add 3. We get m is equal to 2. So 2 is our boundary point. This one is included because it does have the equal to sign on the inequality, so that will be part of your solution. And then we'll continue to test x equals 0 as long as we can. X is equal to 0, or in this case, m is equal to 0 because that's what the variable is. So we're going to m is equal to 0. And so this would be 3 times 2 times 0 is 0 minus 1 minus 0. Remember, all the variable terms become 0. And then it looks like we have 3 times negative 1, because this will be 3 times negative 1 is less than or equal to negative 1. Is negative 3 less than or equal to negative 1? Yes, it is. That is a true statement. So that means at 0 it's true, and then anything in that region would also be true. So everything to the left of 2. So all values of m that are less than or equal to 2. And then the last one, D. We have 2k plus 3 is less than or equal to 2k plus 1. And I need to change that to an equal sign. And we subtract 2k from both sides, and we get 3 is equal to 1. All right, so we have a special case here. We know 3 is not equal to 1, but what is going on in this problem? Because we don't have a boundary point to solve for in terms of k. So you can kind of go back and look at the original problem as 2k plus 3 is less than or equal to 2k plus 1. And maybe that makes sense to you as to what that potentially could be. But let's just go ahead and test a value and see what happens. Let's test the number, continue our number of 0. And 2 times 0 plus 3 is less than or equal to 2 times 0 plus 1. So is 3 less than or equal to 1? No. And what happens if we test any number? Because these 2k will always cancel out. You're always going to be left with, is 3 less than or equal to 1? And 3 is never less than or equal to 1. So that means we have a no solution for this problem. And in the graph, there's nothing to graph because there's no value of k in this case that satisfies the inequality. So this one, we have no solution. There's no value of k that will satisfy the inequality. Question 96. 3 years ago, the average price of a movie ticket was $8.75, and now it is $11. What was the annual multiplier and percent increase? So 3 years ago, the average price. So we have the price. Let's let X or T, either one, represent our time. What year is it? And then we know the Y value equals the cost for the movie ticket, or the average cost. All right. So if we think of this as a table, we can say that at time 0, 3 years ago, the average price was $8.75. And then we didn't know what it was the next year or the next year, but then in 3 years, we knew that it was going to be $11. And so we could use this idea of, and we're looking for an annual multiplier, so we know this is exponential. What is getting multiplied each year to get to the $11? All right, so we can set up an equation here that 8.75 times b cubed is equal to $11. So to solve for b cubed, we need to divide by 8.75, and that'll give us b cubed is equal to approximately 1.26. And then we can take the cube root of that to get b is approximately 1.0, it says 79, so we'll round to 1.08. So what was the annual multiplier? That's the 1.08 it's getting multiplied by. And what is the percent increase? Well, remember, our multiplier, we started at 100%, and then in this case, that 0.08 represents 8%. So if we add 8% to 100%, that gives us the 1.08. Okay? So the annual multiplier was 1.08, and the percent increase was 8%. So make sure you are answering the question. Once again, two questions. Annual multiplier is 1.08 and the percent increase is 8%. Question 97. Factor the following quadratics completely. All right, so once again, completely, think about, is there a GCF? Is there something in common? So 5, 13, and 6, there's nothing in common there, but notice we have 3 x's, 2 x's, and 1 x. So there is an x in common with each of these. So we can factor that x out by dividing each of those by x. That will decrease the exponent by 1, so 5x squared plus 13x minus 6. And then now we can look at factoring the 5x squared plus 13x minus 6. So we got 5x squared and negative 6. We're looking for factors of negative 30x squared that are going to add to 13x. So that looks like that would be 15x and negative 2x. And we do want the 15 to be the positive one so that it adds to a positive 13. Positive 13x, and then it looks like we'll have 5x times x. This would have to be plus 3 then. And then this would have to be x times negative 2. So that looks like it works. So to factor it completely, we're going to have, don't forget about the x, and then times 5x minus 2 and x plus 3. So that's factored completely. All right, let's take a look at B. Now in B, we don't have the same variable, but you'll notice 6, 26, and 8 all have a common factor of 2. So we will take the 2 out by dividing by 2. That'll be 3t squared minus 13t plus 4. Now remember, the 2 still has to go on the outside, otherwise it won't be factored completely. And then now we can factor 3t squared minus 13t plus 4. So we're looking at factors of 12t squared that are going to add to negative 13t. And so that would be negative 12t and negative t. So it adds to negative 13 but multiplies to 12. And then you can put those back in your generic rectangle and then write your dimensions. So this looks like this would be a 3t and a t. That had to be a minus 4 to get the negative 12t, and then this would have to be a negative 1 to get the negative t. So that leaves us with 2 times 3t minus 1 and t minus 4. And that's factored completely. All right, and then on the last one, C. 6x squared minus 24. So both of these have a common factor of 6. So we will take the factor of 6 out by dividing. That leaves us with x squared minus 4. Now, some of you might recognize x squared minus 4 is a difference of perfect squares. So that means we can do x minus 2 and x plus 2. Now, if you don't remember that for your difference of squares formula, that's fine. Just go ahead and use the generic rectangle and the diamond to figure out what your two factors are. Question 98. When a family with 2 adults and 3 children bought tickets for a movie, they paid a total of $27.75. The next family in line with 2 children and 3 adults paid $32.25 for the same movie. Find the adult and children and the child ticket prices by writing a system of equations with 2 variables. So we need to set up our system, but before we do that, we need to define our variables. Let x equals, or let's use a different variable, let's let a equal the cost of an adult ticket, because we already know how many of each. So that'll be in dollars. And then we'll let C equal the cost of a child's ticket. And once again, that'll be in dollars. And so what do we know? Well, we have 2 families. The first family had 2 adults, so 2 times A would give you the cost of the adult tickets combined, plus 3 children, so 3 times C, and theirs cost $27.75. The next family in line had 2 children and 3 adults. So now we have 3 adults plus 2 children, and theirs cost $32.25. So we defined our variables, we wrote our equations, and they're both in standard form, so I would say probably going to use elimination to solve for this. We can... It really doesn't matter on either one of these. A and C both, we could eliminate either one of those. 2 and 3 go into 6, so we're going to have to multiply the top, I'm going to eliminate the a, so we're going to multiply the top by 3 and the second equation by a negative 2. And so the first equation multiplied by 3 would be 6a plus 9c is equal to $83.25. So 3 times $27.75. And then the next one, negative 2 times 3a, so that's negative 6a, minus 4c. And then this is equal to $64.50. So negative $64.50. All right, and now we can add these up. That eliminates the a. That'll give us 5c is equal to $18.75, and then divide by c to figure out how much it costs for a children's ticket. And we get $3.75. So it wants us to find the adult and the children ticket prices. So we got to go ahead and find the adult by plugging that back in. So 2a plus 3 times $3.75 should equal $27.75. So 2a plus $11.25 is equal to 27.75, and then we'll subtract $11.25 to both sides. So 2a will equal $16.50, divide that by 2, and a will equal $8.25. So let's make sure we answer the question. It wants to know the adult and the children ticket, or the child ticket prices. Make sure you put labels on that as well. And so once again, adult tickets cost $8.25 and children tickets cost $3.75. Question 99. Solve the equation below by completing the square. Give your answer in exact or radical form. So let's take a look here. To complete the square, so we have x squared minus 6x plus 3, so let's kind of set up our visual here. We are trying to create a square out of this. We have an x squared tile, all right, and we have negative 6x tile, so we're going to split this up into negative 3x and 3x, which means we know our side lengths are going to be x minus 3 and x minus 3. How many 1 tiles do we need? Well, negative 3 times negative 3 is 9. So we need 9, but we only have 3. So how many more do we need? We need to add 6. And we can add 6 to both sides. So the dimensions of our square are x minus 3 squared. And then we have equal to 6. So now we can take the square root of both sides to solve this using completing the square. That gives us the absolute value of x minus 3 is equal to the square root of 6. And then we can set up our two equations. X minus 3, not 6, x minus 3 is equal to negative square root of 6. And then x minus 3 is equal to positive square root of 6. So if we add 3, that'll be 3 minus the square root of 6, and 3 plus the square root of 6. So this one says give your answer in exact radical form. So those are our two answers. X is equal to 3 minus the square root of 6 and 3 plus the square root of 6. I'm going to go ahead and write it in approximate form also, just to get some extra practice making sure we're plugging these in correctly. So x is approximately, plug in 3 minus the square root of 6 in your calculator, and we get approximately 0.55, and then plug in 3 plus the square root of 6, and you get approximately 5.45. But the question itself is asking for this version because it does say the exact or radical form. Question 100. Multiple choice. Which of the points below is a solution of y less than the absolute value of x minus 3? So I would just say on each of these we're just going to plug them in and see if they work. So is 1 less than the absolute value of 2 minus 3? Is 1 less than, this will be the absolute value of negative 1. So is 1 less than 1? No. So that one doesn't work. B, negative 4 and 5. So 5 is your y value. So is 5 less than the absolute value of negative 4 minus 3? So is 5 less than the absolute value of negative 7? And is 5 less than 7? Yep, it is. So therefore, B is an answer. It doesn't say if there's multiple answers or not, so I'm going to go ahead and keep going. C is negative 2, 8. So y is less than the absolute value of negative 2 minus 3. So 8 is less than the absolute value of negative 5. Is 8 less than 5? Nope. So that one's out. And so let's go ahead and do one more. We'll try D just to make sure. 3 is less than the absolute value of 0 minus 3. So is 3 less than the absolute value of negative 3, or is 3 less than 3? And no, that is not true as well. So it does appear that our answer will be B.